Monsoon, monsoon means during rainy season, water table is rising, rising, rising. Sometimes it touches the ground level also. Sometimes it touches the ground level also. So this is a typical situation. So groundwater table is fluctuating. So how the fate of ultimate bearing capacity decided by groundwater table? Let me tell you, among all the factors influencing bearing capacity, the biggest, the main factor which influencing bearing capacity is, can anyone tell me? Can anyone tell me? Groundwater table. So I can tell you once again, the major factor which influence the bearing capacity of shallow foundations is undoubtedly groundwater table. Groundwater table is having highest impact on bearing capacity. On bearing capacity. There are two methods that are available to compute bearing capacity in case of presence of groundwater table. Precise unit weight, and another one is water table reduction factor. This one is the symbol. W stands for water table, R stands for reduction factor. The another method is which is not much popular like than reduction water. So this reduction factor method is very popular. This is a very popular method. You can find this information in the book VNS Murthy. VNS Murthy, it's a wonderful book. He is a former professor at IIT Kharagpur. Now he is retired. He is enjoying his retirement. He has written a wonderful book, Geotechnical Engineering. You can download the book. The foreign edition is also there. That was published by a great publishing company, Marcel Decker. His book is released in New York City also. Not only he looks like Indian author Murthy. He is a Kannadiga. Presently he is in Bangalore. He is having his own consultancy now. So now precise unit weight, water table reduction factor method. So let us proceed now. So QU is equal to CNC. So we feel the foundation is just a stiff footing. CNC QNQ RW1 plus 0.5 gamma B N gamma RW2. So now you see, you are surprised to see these reduction factors RW1 and RW2. So let me tell you, I will write elaborately CNC gamma DF NQ RW1 plus 0.5 gamma B N gamma RW2. So you may ask, sir, you are writing W1, then you write here gamma 1. మీరు కూడా gamma 1 అని రాయండి అని మీరు చెప్పొచ్చు నాకు. Sir, you are writing gamma, please write here also gamma 2. So what I am trying to tell you, RW1 0.5 1 plus ZW1 by DF. RW2 0.5 1 plus ZW2 by B. So this is the equation to calculate ultimate bearing capacity. What is RW1 and RW2? Water table reduction factors. Water table reduction factors. So now what is my water table is somewhere here. You see, water table is between ground level and base of the footing. This I would like to write here, base of the footing. Base of the footing. Now what I am telling you, what I want to speak with you. So here it is ZW1. ZW1. This is the position of water table. Now what is RW1 now? 0.5 1 plus. Actually this is an equation which shows interpolation. Interpolation, you know, in mathematics, interpolation, the between value. So I will try to explain. I am not in a hurry. ZW1 by what is this? DF. Now you see DF. See, sometimes people ask me, sir, how you are remembering this equation? See, here it is ZW1. You see, from ground level, ZW1. So depth. That's why I'm writing ZW1 by depth. Now you see how I will write RW2. Get ready now. So this is the influence of the width. So now this is the base of the footing. Can anyone tell me what is this distance? Come to water table. What is this distance? ZW2, which starts from base of the footing. ZW1 starts from ground level and ends with DF. Now you see I have ZW2 which ends with influence of width. Okay. Now can anyone tell me ZW2 now? 0.5, 1 plus. Can anyone tell me what is RW2? RW2, water table reduction factor. 0.5, 1 plus ZW2 by within the influence of width. This is what I actually many times people are asking, sir, we know 0.5, 1 plus, but we are not able to write what is ZW1 or ZWC. Don't get confused. This is depth. Within depth, water table is there. Within influence of width, water table is there. This I would like to call ZW1. This I would like to call from base of the footing ZW2. That's why these equations are like this. Now, can anyone tell me how to calculate ultimate bearing capacity once again? U is equal to help chestara the footing CNC. Now someone can ask me what is gamma 1? This is gamma 1. So backfill soil, unit weight of the backfill soil. What is gamma 2? What is gamma 2? Unit weight of the soil below the base of the foundation. Let me tell you, this is the base of the foundation. Here two interfaces are there. One is base of the foundation, another one is ground level. Okay. Now CNC, gamma 1 DF, NQ, RW1. Okay. Now 0.5, gamma 2, B, N gamma, RW2. ఇప్పుడు మీలో ఒక స్టూడెంట్ అంటాడు, సార్ ఇది ఈక్వేషన్ మాకు బాగా తెలుసు, మీరు ఇప్పుడు గామా 1 గామా 2 అని విడగొట్టారు. ఒకటి గామా 1 ఏమో అబౌవ్ ది బేస్ ఆఫ్ ది ఫౌండేషన్ గామా, బిలో ది బేస్ ఆఫ్ ఫౌండేషన్ గామా. ఇఫ్ సేమ్ సాయిల్ ఉందనుకుందాం, లెట్ us assume soil is homogeneous, then gamma 1 is equal to gamma 2 is equal to gamma. So we are very happy, sir. అలాగే మాకు RW1 వాటర్ టేబుల్ లేదు. Just tell me first condition. Groundwater table is far away from the footing. That means, let us say now, this is my footing, and also that this is width of the foundation, and this is the depth of the foundation. Now the thing is, I have a table which is very far from the footing. Now what is RW1? What is RW2? So here you see water table is here. What about ZW1? Can anyone tell me? ZW1 is equal to DF. So once ZW1 is equal to DF, what is the value of RW1? 1 plus ZW1 by DF. So ZW1 is equal to DF. Can anyone tell me what will happen? DF by DF. Can anyone tell me 0.5 into 1 plus 1, 2? How much it is? Everyone me manaslo on mat bite pattern. Just speak now. For example, here you see water table is here. What I am trying to tell you, ZW2 is equal to B. ZW2 is equal to B. What is RW2 now? Are you there? ZW2 by B. Can anyone tell me what is RW2? 0.5, 1 plus. Please tell me. B by B. So what is the answer now? What is RW1? What is RW2? If water table is here, far away from the footing. ఇక్కడ లేదు, ఇలా లేదు, ఇక్కడ లేదు, ఇక్కడ లేదు, ఇక్కడ ఎక్కడో దూరంగా ఉంది. అప్పుడు RW1 ఎంత? What is the RW1?
1.
చెప్పాలి. 1. అతను నా స్టూడెంట్. What is RW2? 1. Let me write the condition 2 now. Condition 2 ಒಂದು groundwater table is at the base of the foundation. Are you there? Base of the footing. So now what is the bearing capacity? Okay, are you ready now? So please tell me. So my question, I will draw the figure. You can see now, this is the figure what I am drawing. This is the position of the ground level, and this is a footing foundation. Footing is an embedded one. You know that footing is embedded in ground, embedded system. So no doubt it is buried in ground. This is the depth of the foundation is written already, width is given. Now what I am asking you, if water table is at the base of the foundation, if the water table is at the base of the foundation, ఇక్కడ ఉంటే, so what is RW1, what is RW2? So పలికే బంగారం అయినట్టుగా మీ పలుకు పలికించండి. So what is 0.51 plus ZW1 by DF? What is 0.51 plus ZW2 by DF? అమ్మా చెప్తారా? ఎవరైనా చెప్తారా? ZW1 ఎంత? ZW1 is equal to DF. What is ZW2? ఎంతమ్మా కరెక్ట్గా ZW2 ఎక్కడ ఉంది? It is at, this is, I would like to write base of the ZW1 starts from ground level, ends with depth. Whereas you see ZW2 starts from base of the footing, it ends with influence of width. So what I am telling you now, ZW1 is DF because there is no water table here. Water table is at base. ZW1 is equal to DF. What about ZW2? Can anyone tell me? 0. ZW2 is 0. So
RW1 1.
RW1 is 1. What is RW2 if ZW2 is 0?
0.5.
0.50. Absolutely correct. Now can I write now bearing capacity equation? To compute ultimate bearing capacity, CNC. This one is gamma 1. This one is gamma 2. But don't forget it is saturated. Don't forget it is saturated. Water table is there. Get ready now. QNQ. Gamma 1 DF. Yes, gamma 1 into DF. Gamma 1 into DF. NQ. RW1 is 1. So now anyone ready to help me now? 0.5. What I have to write? Gamma. ఇంకా మిగిలి చేశాను మీకోసం. Pn gamma చెప్పండి into RW2. ఎంత రాయాలో చెప్పండమ్మా. చెప్పండి. What is what I am supposed to write here? ఈ గామా ఏం రాయాలి చెప్పండమ్మా. గామా 1 రాయాలా, గామా 2 రాయాలా? Strictly speaking, is it gamma or gamma saturated? That is my first question. So, and the second question, what is the value of RW2? చెప్పండి. ఇక్కడ ఏం రాయాలమ్మా? ఇక్కడ ఏం రాయాలి? Gamma 2, which is saturated. జాగ్రత్తగా చూడండమ్మా, ఇదే మీకు రేపు ఎగ్జామ్ లో పడే క్వశ్చన్. Gamma 2 saturated. What I have to write here? 0.5. And also ఇక్కడి వరకు కాదు, ఇంకా పైకి వెళ్ళిపోయింది. అంటే ZW2 0, ZW1 0. What about RW1? 0.5. And one more point, మనం అందరు ఫ్రెండ్స్ కాబట్టి ఈ పాయింట్ కూడా మీకు చెప్పేస్తా. Gamma 1 is saturated and Gamma 2 is also saturated because water table is at ground level. Get ready now. 0.5, 1 plus ZW1 is 0. ఇది 1 0. Gamma 1 EF NQ into 0.5 gamma 2 B N gamma into ఇది అంతా పూరించండి. Please fill the blanks. And I want to listen from you what is gamma 1 and what is gamma 2. Condition of the ground. గామాస్ ఏం చెప్తాయండి మనకి? గ్రౌండ్ కండిషన్ చెప్తాయి. గామాస్ మనకి ఏం చెప్తాయంటే డ్రైగా ఉంటే గామా డి, పార్షియల్గా ఉంటే గామా, వాటర్ ఉంటే సాచురేటెడ్, వాటర్ ఉండి తన నెత్తి మీద వరకు ఉందనుకోండి సబ్మర్జ్డ్. సో ఇప్పుడు చెప్పండి, తడవడం వేరు, మునగడం వేరు. తెలుగులో మాట్లాడినందుకు క్షమించండి. మనిషి తడవడం వేరు, మునగడం. I don't know. So now can anyone tell me now how to calculate reduction factor to water table in case of groundwater table is at 0. So now can you tell me now what is the answer here? Is it 0 or 0.5? 0.5. 0.5. Now what is this one? 0.5. 0.5. True picture. you can use precise unit weight method. Precise unit weight method, how that method is originated, I am telling you. Gamma sat into 0.5, gamma sat by 2. Gamma sat by 2 is approximately gamma prime. What is gamma prime? Gamma submerged. So one can replace saturated gamma with submerged unit weight. Then just by avoiding this gamma into 0.5, your gamma sat into 0.5, you can replace these two terms with a single term that is called gamma submerged. This method is called precise unit weight method. But someone can ask me, sir, why you are interested to speak about reduction factor method? Because reduction factor method is not giving any confusion. And also, sometimes a student is coming and asking, sir, if water table is here, for example, let me tell you, this is a case 4. Let me draw the footing first before we start this case. So water table is at intermediate. That means, let me tell you. So if the water table is here, let me say this is ZW1. I can tell you, this is the, what I say, depth of foundation. This is 1 meter. But this ZW1 is just 0.5 meters. Now, can anyone tell me how to calculate RW1 and RW2? And no doubt the water table is rising even above the base of the footing. Now, how to calculate RW1 and RW2? Can anyone tell me? 0.5, 1 plus ZW1 by DF. Now we have RW2 here, you see water table is already rising. That means here you see ZW2 is 0. So now what you are trying to say, RWT is 0.5 into 1 plus 0 by B within the width of the footing. So now anyone ready to tell me now how to calculate RW to RWT is 0.5? Because water table is already above this. Above this means it is already in submergence. The soil below the foundation is in submergence. Now the situation it is at a very interesting position. It is in between the ground level and base of the footing. So how to calculate now RW1 0.5 into 1 plus, I know ZW1, it starts from ground level, it is 0.5. So what is the depth of the foundation? It is clearly written, it is 1 meter. I will write once again. If you feel it is not visible, the foundation is 1 meter. Now anybody ready to tell me how to calculate RW1? Now what is the answer? 0.5 into 1.5. So what is the answer now? 0.5 into 1.5. Hello? What is the answer?
0.75.
0.75. Now let us proceed now. Bearing capacity is equal to CNC gamma DF NQ RW1 0.5 gamma B and gamma RW2. So now we got an expertise dealing with RW1 and RW2. Now we need to think about gammas. Gammas, no doubt this is gamma 2. Gamma 2 is saturated. I can write saturated. But now I need to take a decision about gamma. Elaga? Em cheyamantaru? Meer naku advice istara. Chappani gamma ela teeskoni gamma 1. How to select gamma 1? Anybody ready to help me now? How to select gamma 1? ఎందుకు నేను మీ అడ్వైస్ తీసుకున్నాను అంటే ఈ పైన ఉన్నది గామా, కింద ఉన్నది గామా సాచురేటెడ్. అప్పుడు నేను ఎలా చేయాలి? హౌ టు క్యాలిక్యులేట్ గామా 1? Because your situation is quite complex while I am selecting gammas. So what I have to do now? I have to go for gamma average, gamma weighted average. You know how to calculate weighted average? Weighted average. Gamma above water table into ZW1 plus gamma below water table into E depth. Can anyone tell me what is this distance? Ela chappachu cheptaru evaraina? E depth. E depth 1 minus 0.5 divided by total depth. Divided by total depth. This is one way. Actually, the textbook, you see, in the textbook they have done like this. Gamma. Ikkada mistake చేస్తారు మాట. అందరూ ఏంటంటే ఇక్కడ మిస్టేక్ చేసేస్తారు. ఎందుకు మిస్టేక్ చేస్తారంటే దే ఆర్ మేనేజింగ్ ది థింగ్ యాక్చువల్లీ. ఏదో గామా సెట్ వేసేద్దాం అని అనుకుంటారు. but it is not gamma, it is not gamma saturated. It has both. It has both undi ఇక్కడ 0.5 ఉంది కాబట్టి పర్వాలా మీకు తొందరగా అర్థమవుతుందని 0.5 చెప్పా. ఒకవేళ if it is ZW1 is 0.3, if ZW1 is 0.3, then the weighted average definitely gives a good result. So the thing is, how to calculate gammas also you should keep in your mind. Okay, gamma 2 is saturated, there is no doubt. Gamma 2 is saturated. Now I will present one case. So I hope, yeah, I expect answer from you people. The case for 5. Now the water table is here, you see. Let me tell you, every time I need to draw the figure. This is depth of foundation. Undoubtedly, this is width of foundation. Now water table is somewhere here. Let me tell you, the water table is somewhere here. See, this is ZW2. I can tell you width is 2 meter and depth is 1 meter. So now water table is at 0.5 meter. So how to calculate RW1 and how to calculate RW2? So now the groundwater table is below the base of the footing, but within the influence of width. So hope it is visible. So okay, are you ready now? So please tell me. The time అయిపోతుందండి, అందుకే మిమ్మల్ని నేను రిక్వెస్ట్ చేస్తున్నాను. RW1 is equal to 0.5 into 1 plus ఇక్కడ వాటర్ టేబుల్ లేదు అంటే ZW1 is equal to DF by DF. వాటర్ టేబుల్ లేదు అంటే చిన్న లాజిక్ చెప్తాను చూడండి. క్లాస్ అయిపోయే ముందు ఒక చిన్న విషయం చెప్తా. వాటర్ టేబుల్ లేదంటే ఒకటి, వాటర్ టేబుల్ ఉందా లేదా? ఉంది, ఎక్కడో మధ్యలో ఉంది. లేదు 1, RW2 1. వాటర్ టేబుల్ లేదనుకోండి, within influence of width lo we will say RWT is 1. Now can anyone tell me 0.5? What is the value of ZW2 right from base of the footing? ఇది మర్చిపోద్దామా, ఇక్కడ 2 levels ఉన్నాయి. From base of the footing, this is ground level. Are you ready now? 1 plus what is ZW2? 0.5. What is the width of the foundation? Chapali 2 meter. So what is the answer now? RW2. What is RW2? Chapalama tondaraga. 0.625. Now what is the equation for calculating bearing capacity? CNC gamma DF NQ RW1 0.5 gamma BN gamma RW2. విచిత్రం ఏంటంటే మనకి ఇప్పుడు RW1 RW2 గ్రిప్ ఉంది బాగా. మనం ఇప్పుడు we are fighting with fundamentals. What gamma have to write here now? What gamma have to write here? Gamma 1, gamma 2. Are you there? What is gamma 1? Gamma 1 will be gamma if it is dry, gamma. So the gamma 1 is gamma. How to calculate gamma 2? ఇప్పుడు ఇదైనా చెప్పనమ్మా ఎవరైనా, how to calculate gamma. So as you know, this is gamma saturated. Are you there now? How to calculate gamma 2?
Gamma average.
అంటే gamma into ZW2 plus gamma sat into ఇది means I can tell you 2 minus 0.5 1.5 by 2 అయితే మీరు లాస్ట్ గా నేను చెప్పే మంచి విషయం ఏంటంటే అండి, ఒక మంచి విషయం చెప్తాను. వాటర్ టేబుల్ లేకపోతే 1 అని, వాటర్ టేబుల్ ఫుల్ గా ఉంటే 0.5. సో మనం చేసింది ఏంటి ఇప్పుడు? ఇంటర్పోలేషన్. మళ్ళీ చెప్తే చూడండి, మనం చేసింది ఇంటర్పోలేషన్. వాటర్ టేబుల్ ఉంది 0.5, వాటర్ టేబుల్ లేదు 1 అంటే ద గేమ్ ఈజ్ బిట్వీన్, మీరు కట్టే రిడక్షన్ ఫ్యాక్టర్స్ దేని నుంచి దేని మధ్య ఉన్నాయి? 0.5 to 1. వాటర్ టేబుల్ లేదనుకోండి, అసలు ఈ గొడవే లేదు. మీ గామాలు అయిపోయినాయి, మీ RW1 RW2 2 1 అయిపోయినాయి. మీ ఈక్వేషన్ మీకు ఉంది కదా.